So good afternoon. Today we're going to see about the fifth unit topic in a BEEC subject, that is the basic electric and electronic circuits. So today we're going to see about closed loop gain topic. So what is this closed loop gain topic? So what is a gain? So gain is an important parameter in all electronic circuits. Okay, so in this today's session we're going to discuss the following topics, that is first why we are using this gain for our applications, and next how it supports the performance of the customer, and how any problem statement that depends upon the gain value, then what is a closed loop system, and what is a closed loop gain. So generally we have two types of loops, positive loop and negative loop. So depends upon the positive loop and negative loop, the amplification factor and the gain calculation is carried out. So what is a gain? So that is output by input. Okay, the output terminal divided by input terminal, or the if for example if you are using the voltage gain, then output voltage divided by input voltage. If it is a current gain, then there is a current output current divided by input current. So likewise we are calculating the gain value. So how this amplification supports? So it supports the stability of the system. So whatever the signal that conveys or passes in a particular system, the stability remains constant, depends upon the loop system. So this loop gives a better stability for the given circuit. So this is the thing we're going to observe in the user needs. So how it supports the amplification, how its signal output is classified, and how the real behavior is classified. Okay, next what is the real problem? So the real problem is based on the gain variation, then the stability get varies. So due to the stability variation, some noises will add in the signal, so that noises will be called as the signal distortions, and sometimes due to our device temperature effect, there will be some noise availability in the signal. So this will also degrade the signal stability. So to give a optimized and a positive signal amplification with a full stability, we'll be using this the closed loop gain. So here we are how we need the system. We have to build a system based upon the problem statement, how it's we have to calculate the gain, and how the we have to maintain the stability, and because of the stability how the system maintain the reliability. So this is the concept that undergo with the topic of closed loop gain. So next is the closed loop system. The output feedback is give as a input. How the system get works is the output is given as a feedback to the input. So it controls the system, it improves the performance. So how this feedback concept worked? So it is about the negative feedback. So every a positive feedback means it will give only the positive gain, so where we'll cannot maintain a proper stability. If it is a negative feedback path, so we'll be obtaining a proper stability in the system, and also we'll be getting the good amplification factor. So how this closed loop gain supports the stable? With this I have given you a simple formula to calculate the feedback factor. So with this feedback factor only we can see about what is a how to calculate the positive feedback and how to calculate the negative feedback. So that only I have given the formula. So A divided by 1 plus A into beta. So what is A? A is the gain, and 1 is the formula, A is the again is the gain, and beta is the feedback factor. So see in this thing, this is a general formula that we have to use to calculate the closed loop gain. So likewise I summarize the session. So how a closed loop gain initiate the session is, it is started with how we are giving the user needs, and how we create the problem statement, and how we calculate the stability and amplification factor. So with this we summarize the closed loop gain session. So this is a simple quiz I have given on the topic of closed loop gain. So this is the answer for this gain. So these are the reference for this particular topic. And with this, we stop here the session. Thank you.